Hello there, hope you're all doing great. We at Zifo have built a native app in Snowflake that engineers de novo antibody sequences with the help of AI ML models. Without further ado, shall we jump into the demo? You can download or install our application from the marketplace, and once installed, you can come into this app session and you can see our application listed here. So you just click on it and you'll be redirected to our native app. In this Settings tab under Privileges, you can see there are a list of privileges that's required for this application to run. You will have to click on the Edit and give permission to all of these privileges and click on Update Privilege. And there are no object access privileges required for this application. So let's move on to the Connections tab here. Yes, we do require some external API hits for this application to run successfully. So yeah, we have got a couple of endpoints that are used by this application. You'll have to allow access with these endpoints to be accessed by the application. And once that is done, let's move on to the access management part. This application is currently run by the account admin. If you have to provide access to another account role, you can just click on the add and you can add on any role that you want. Let's say I select this role. Since there is only one application role available, which is the app user, that is what will be used by the account rule, and once done, you can just close it. And to show you that these account rules can access this application, let me move on to another account. Say, let's select another role apart from account admin, which is SPCS role that has access to this application. And yeah, here you can see the application listed. Once you click on this, you'll be redirected to the application page. And you can cross-verify all the other privileges required for this application and can launch the application. So this is the landing page. For application, which has 3 different pages: main page, settings page, and supports page. Under main page, what you can see is you can list all the resources that are used by this application. Say, for example, compute pools and the services used by the application. Currently, since no resource has been started yet, it is empty. And if you want to start a resource, you can go on to Create Resources and then click on Create Service. The services required and the corresponding compute pools required to start a service will also be started in the backend, and you'll see a message stating that we are waiting for the service to start. Once the service has started, it will automatically move on to the next step, which is the Activate Service step. When the status of the service moves from pending to running, it'll move on to the next step, where the logs of all the services that's being run will be displayed in a user-friendly way. This might take a few seconds, or even 2 to 3 minutes, because the compute pool has to be started, it has to be resized, and it has to be assigned to the services. Will be in pending state up until the compute pool is being assigned to it. Once the compute pool is assigned and the service is ready to start, then its status turns to running. Now that we have refreshed it, you can see that the compute pool is active and we have 2 different services. Both of the services are in running state currently. And since the services are already running, you can just click on Proceed to go to the next step. But before that, let's see what's there in the other pages. Under Settings tab, we have these options where we can either suspend, resume, or drop the resources. Resources in the sense compute pools and services. Just in the click of a button, avoiding all the SQL query typing and stuff. On a click of a button, you can resume, drop, or suspend the resources. Going to the Supports tab we have given in SQL Editor, where you can type in any of your SNOSQL commands, say. And when you click on this Run query, the result of the query will be displayed below in a table format. Let's go back and see how this service is running. So, since the service is already running, you have this Proceed button here, which is available, and click on Proceed. It will be proceeded to the next step, which has all the logs. Yeah, now that our Streamlit application has started, it'll automatically move on to the next step, where the Streamlit application URL will be displayed. This might take a few seconds because we are loading some sample data, which is the OAS data, onto your Snowflake account in form of tables. Once that is done, you'll be able to get the URL for the main Streamlit web application. Voila, you've got the URL for our Streamlit application. And if you are unable to access this URL, you can just contact your account admin, whoever that is, and check what they can do for you to be able to access this URL. Let's hit this URL and see the magic happen. So I log in with the account that has the access to this native app. And here we are. This is the homepage of our Streamlit application, and under homepage, we have a short summary on what this application is. And we also got the workflow diagram of both the native app and the entire setup. Moving on to the user guide. Here are the steps that you'll have to do in each and every feature or page in this application that is being displayed here. So we have two main features in our application. One is fine-tuning your own custom model with your own custom data and saving that model into your stage and using that saved model to generate sequences. The main perk of this application is that we let you fine-tune a model with your personal data. So that you don't have to go and generate sequence on a pre-existing model. This model that you use will be trained on your own data, which makes it much more easier for you to use. And under Fine-Tune a Model tab, we have an option for you to select which model you want to fine-tune. And there is also an option where you can choose which mode you're going to use the data from. Either you can use the default OAS dataset that we have, or you can upload a CSV file. In case you upload a CSV file, it should be of this following format, and the first row should always be a header so that we don't run into any errors. And the other option is where you can fetch your own tables that has your own data from your Snowflake account. Yeah, and if you're uploading a file or fetching a data from Snowflake, select the right columns, see heavy chain and light chain columns. From the data that you have selected, and you can start the fine-tuning process. Once you start the fine-tuning process, it will run in the background. It will fine-tune in the background. Once that is done, you will get all the results of the fine-tuning, and you can also see the progress of the fine-tuning. On to the next feature, which is generating the sequence and structure using the saved model. You have an option to select whichever model that you want. And under that model, whichever model that's saved into your stage will be displayed too, where you can choose. If you've saved multiple models, then you can choose from those models too. And you'll have to enter the template mask sequence if it's needed. Based on the model type that you select, you'll have to choose the number of sequences to generate. And when you click on the Start Generate Process button, then it'll generate the sequence, and those sequences are being validated by Anarchy. Visual display of the generated structures are also there, where you can also download all the results that comes with it. The PDB file and the generated sequences will also be saved to your stage. And under Model Descriptions tab, we have used 3 different models, ESM2 Prot GPT and RoBERTa. And the short description on each of these models are also present here, which you can go through. And based on your use case, you can select whichever model that you want among these 3. Moving on to the fine-tuning page. As I've already said, we have 3 different models among which you can choose whichever model you want. Say right now, let's choose ESM2 model, and we also have 3 different options. Currently, let's use the use default data. When you click on the Upload a File, you'll have a drop-down area where you can drop your file or select a file that you want. It should be of CSV format, or you can even fetch tables from your Snowflake account. We have by default given you 4 different tables which all has OAS data in it. But then let's go with a smaller data set, which is this use default data with around 100 records. You can even see this data by click on this download CSV file on how this data looks like. And you can save your model in with whichever name that you want. Let's have the same name so as not to confuse ourselves. And let's train this with around 10 steps. And these 3 are all the hyperparameters that are used for model training. And what each of these hyperparameter means are given in these help buttons. When you hover over these, it'll show you what each and every hyperparameter means. And let's run this fine-tuning. Since it's a smaller data, it'll take only a few seconds, around a minute or so. But if you have a huge data, it might take some time to fine-tune the model. Yeah. Now that our training is completed, the model is being saved and staged into your account. As we can see, these are the results of the model training. Shall we jump into generating the sequence for the model that we right now saved? In Generate Sequence tab, we'll select whichever model that we want. Since we trained ESM2 model, let's select that ESM2 model. If I select any other model, then if I have any model saved under this model, then it will be displayed. If no, none will be displayed. We freshly have only ESM2 model, and under that we saved 2 different models. The one was saved yesterday. So let's use freshly trained model, which we did today. And you can enter the templates of heavy chain and light chain sequences here. For now, let's generate two sequences and the sequence to be saved in whichever name can be given here. Let's just go with the default and click on the Generate Sequence and Structure. Generating sequences might take a bit longer than fine-tuning because the models that's needed for generating the structures will be downloaded in the back end into your stage, and then those models will be used for generating the sequences and structures. So this might take a bit of your time, but let's wait. Once the generation is complete, you can now see that all the sequence and the structures that were generated are being displayed here, which looks very colorful. Yes, we generated two sequences and we can switch between them too. And we have a few visualization options. You can choose any of these visualization options. Let's just go with the colorful rainbow one. And you can also choose to show or not show the side chains and main chains if needed. And the results of the anarchy are also displayed here when you click on them. And you can download them separately as CSV files. The scores from the anarchy are also displayed here. In a session, if you run multiple times for each run, the columns will be appended here, and you can also download this session history. The PDB file can be downloaded by clicking on this. The CDR results are also displayed here, which is also downloadable. And the generated sequences are also here. As we already saw, the PDB file and the generated sequences will be automatically put into your stage, but still you can download them as CSV here. Yeah, so generation of sequence only takes longer for the first run. Say if I generate 3 sequences now, it should be much quicker than how long it took in the initial run. Yes, now we have 3 different antibody sequences that we can shuffle through. And if we go here, since we did 2 runs, both of the runs anarchy results are available here. Moving on to the final page, which is the troubleshooting page. If you run into any errors, you can just download this log file to check where the error occurred. Or if you want to see and manually work on those errors, you can just click on this link where we have spun a Jupyter notebook for you to use. We also added some pre-existing code snippets, which basically does GPU availability checks and stuff which you can run easily. So this is the notebook script. And yeah, you can check how many GPUs are running and what is running on it. And you can type your custom Python code to debug too. In case of any emergencies, you can contact us on this email ID and we'll be of assistance to you. Thank you. And a final reminder, don't forget to go and stop your services once you're done, which can be done in this native app settings page. Currently, everything is active and running. So let's go to the Settings tab. If you want to suspend, you can do that too. But I'm going to drop the resources. I'll just drop the service. And I'll drop the compute pool too. And now, since no other resource is available, it is empty here. Back to square one. Thank you.